this lab, we're talking about the photometric determination of iron. Basically, the end result is what we want to do is we want to take a sample, an unknown sample of iron, and tell me how much iron is in there. That's sort of the end result of this thing, isn't it?
It is, yes.
But to do that, we have to go through a number of different steps. So, Scott, can we get started? We basically get to do two things today, right? Play with burettes.
And play with a spec. The spectrophotometer, yeah.
The spectrophotometer. It looks pretty good.
It does. If this was state of the art in this 1969, it's very digital.
Oh, good. Do we have a newer one?
No.
No? All right. Hey, well, let's get started.
Okay, so first of all, some things you're going to be using today. First, this is your iron solution, okay? It is in 0.002 milligrams per milliliter, or 2 parts per million. Now, in order to get the iron to dissolve into solution, there is sulfuric acid in this solution, so be careful. Use your gloves. Don't drink it. Don't eat it. Don't lick the sides of the container, okay? It is actually quite caustic. You don't want to be getting this stuff on yourself.
Have you ever licked a container?
No.
Okay.
Not yet. Okay, some of the other things, 2 molar potassium thiocyanate. We all know what cyanide is used for. Okay, most of the time it's used to poison rats. So we want to avoid, again, we don't want to get this on our skin.
No licking the container.
No licking the container on this one either. Okay, it is 2 moles per liter. It's a little bit more concentrated, so again, be careful. And of course, our 6 molar, the most wonderful thing in our lab, 6 molar nitric acid. This stuff will actually burn you quite badly if you get it on your skin. So you want to make sure you're wearing gloves. Sorry, Elio, I keep moving the thing around, I know. We want to make sure you're wearing gloves and long sleeves. Make sure you wear long sleeves to this lab, please, if not a lab coat. Okay, now what you're going to do, these are burettes, okay? And these are actually 50 ml burettes that we have in the containers here.
How much do they cost?
About $1,000. Okay. They are quite all jokes aside, they are quite expensive. We don't have very many of them. We only have 17 or 18 of these wonderful units. So you just want to make sure that you're careful with these. Now they are graduated to the 10th of a milliliter. Some of them have white graduations on them. I don't understand why either. They are hard to read. If you have trouble reading one of these, make sure you put a piece of paper behind it, and it makes it much easier to read. Okay. Now, 50 ml burettes, these have glass tips on them, glass burette tips. They're also made of glass themselves, and they have a plastic, what's called a stopcock. Now, when you combine glass and ceramic, it tends not to be a very good mix. Okay, so in your sink, you notice around the room we have ceramic sinks. In your sink, in order to fill this up, okay, you're going to fill it up over a sink, and you're going to fill it up with a sponge below the tip, because these tips are very breakable. They are very expensive. If the tip breaks, we generally have to throw out the whole thing. So make sure that you have a sponge below your tip when you're filling the burettes. And I'm just going to go find one. I'll give that to you.
Thank you. We get to fill this one up with water?
Yeah, one of them gets filled up with distilled water, so I'll let Jeff go ahead and do that.
Can I do that?
Yeah.
Just like this?
That works.
Is it going to take me forever?
Okay. Now what you want to do with your burettes?
Oh, it's closed. That's a good thing.
It is a good thing. Okay, what you want to do with your burettes is what Jeff's doing right now, is once you got it up out to there, okay, you're going to take the burette. Sorry, Jeff, I'm taking things away from you.
Go ahead.
Well, you're going to take the burette, and you're just going to tilt it and rinse it once with your distilled water. Okay, not only that, but you're going to take it and flush out the tip. Okay, this ensures that there's no contamination in your burette from last week's lab. Okay, it also ensures that you have a clean burette. And once you've done that, the rest of it goes down the sink.
Oh, so we clean it once first?
Clean it once first,
regardless
definitely.
of whether it looks clean or not?
Regardless, yeah. And now we're going to fill it up. So again, with the tip on the sponge, you fill it up in the sink. Okay, and you're going to fill it at least 2 milliliters above the zero. A little bit more. Perfect. So once you got it to there, what you're going to do, thank you, Jeff. I feel to keep taking things away.
My pleasure.
What you're going to do is you're going to flush out the tip again. I'm just going to borrow this beaker here just so we can show this without using the sink. You're going to flush out the tip again so that there's no air bubbles left in the tip. And the reason why you go for more than 2 mils above is so you can make this rest on the meniscus rest on the zero mark.
Perfect.
Yeah. Not my first time at the rodeo. Okay, so put that back in the burette rack. It's right on the 0 line.
With distilled water.
With distilled water. In the other burette, you're going to put your iron solution. And again, same type of thing. Okay, make sure you're not using a funnel for this. Slowly but quickly, you're going to pour this into your burette.
We want to clean this one again.
Again, exactly the same way, tilting it on its side and turning it between your fingers. Okay, and you'll notice I don't need a whole lot of solution to do this, just enough so that I can spread it all the way down. Again, we flush out the tip.
He's doing that in the sink, by the way. He's not just sort of
dumping it on the back of the room.
Anyway.
Okay, and again, we rinse out the burette. And once we've done that, again, slowly but quickly pouring this. Ooh. This part does take a little bit of talent, by the way, folks. Don't worry if you spill it all over yourself, you'll be over a sink.
You're almost there. Good.
Again, just above the line. Okay, we want to take it, flush the tip, and make sure we're right at 0.
Perfect.
Okay, now, it is important that you label these burettes. Okay, both solutions are clear. Make sure you labeled one as distilled water and one as your iron solution.
They both look the same.
They do. They look very identical.
Why would you do that?
So you don't get them confused. Because if you put 20 milliliters of water, your indicators are going to take a long time to change. It takes a long time to find iron in distilled water.
Yeah. Another reason is since we have limited numbers of burettes, you may be sharing some of the burettes, right?
Could possibly be. I'm hoping not.
Hopefully not. But if you happen to, when you come, you'll know which is which.
Okay. Yeah. Make sure that they're labeled. Okay. Now, next step is you have a chart in your lab. I'm just going to steal the lab for a sec.
Yep.
And it is a very good chart, but it is at times can be a tad bit confusing. Okay. It's this chart right here. And what it states, it gives you, first of all, the volume of iron solution, the volume of water solution, and then it gives you the concentration in parts per million. It is on both sides of this page. So this is the first 3 test tubes, these are the second 3 test tubes. What you want to do, okay, what I would suggest doing, this is just a suggestion, you can do it many different ways, but this is the way I would suggest doing it, is first of all, filling all of your distilled water first. So putting distilled water in your large test tubes, all 6 of them first. So in the first test tube, I'm going to fill it with 20 mils of distilled water. And you simply turn the stopcock in the burette. You'll notice it comes all the way down, it keeps going, the meniscus keeps coming down until...
Down, I'm pointing that just for camera.
Just for camera purposes?
Slow down.
Until we get to...
Oh, very good.
20. Okay.
20.
So that is exactly 20 mils of distilled water.
Probably help to label these test tubes too?
Yes, it would definitely help to label these test tubes. Make sure you label this one as your 0.00 parts per million. Your second test tube, it requires 18 milliliters of water. So again, you go from your 20, your initial reading is 20.
You're sure that's water?
I'm positive this is water.
I don't see it labeled.
No, but it should be labeled as water.
I'm just trying to mess with you.
No worries. I'm unmessable some days.
So 18. Now it looks like we're going down here to 18. We've got another 4 test tubes.
Oh, for sure.
We'll have to fill this up with more water.
Definitely. And for this one at 18, you're going to stop at 38, at the 38 mil mark. Now, once you're to there, your next test tube requires that you have 16 mils of water. However, in our burette, we only have 12 milliliters of water left. So,
fill it up.
Back to filling it with distilled water. Now, in order to do that, please do not do this. Okay, some people are more vertically challenged than I. Okay, please do not try and reach and fill your burette this way. You will not be able to see the 0 mark. Okay, so make sure you take your burette out, you walk over to the sink, you put the sponge back in the sink, and you fill it up that way.
That's good. Yeah,
okay.
Good.
So.
No, we're not going to do the other ones. We'll just do those 2. Is that all right?
We'll just do those 2. And what we'll do with the second one requires 2 milliliters of your iron solution to give you your, I believe it's 0.2 milligrams per milliliter. So you're going to fill this just with 2 mils. Now be careful because this goes very quickly.
This one goes fast.
Okay, so you go 1, oops.
It's not going at all yet. Oh, there it goes.
2 mils. Okay, now.
You'd have to sort of stand up to see the meniscus, eh?
You do a little bit.
Do you have any stools?
We do have stools, yes.
Okay.
We actually have stools for this very
The
reason.
burette stools.
No kidding, yeah, really we do.
All right, okay.
So there will be some kicking around for, we'll call it vertically challenged
if you need
people.
to stand up to see the meniscus. All right,
Yeah.
good.
Now, what you're going to add in, again, the nitric acid always goes first. Okay, make sure you keep these in sequence. Okay, so again, with your 2 test tubes or with your 6 test tubes, your 6 and your unknown test tube, which has exactly 20 mils of liquid in there.
Right here.
Okay, what you're going to do is you're going to add first, you're going to add 10 mil or 10 drops of 6 molar nitric acid
To each one of them.
to each one, and do it. Make sure that you're consistent. Make sure your drops are the same size. Make sure you add the same amount of drops. Make sure that you're, in general, spending the same amount of time over each test tube.
That's pretty good. You could talk while you counted. I thought that was pretty good.
Well, did I get 10 in each?
I think so.
I was just guessing, but I'm pretty sure there was 10. But this one's kind of the kicker. This one does take a long time. Okay, this is 2 molar potassium thiocyanate. You need to add 40 drops of each. Okay, so even though you will not notice a change in your control group, which is your 0 parts per million, you will notice that the solution turns red in all of your other tubes.
Because there's a bit of iron in there.
Because there is a bit of iron in there.
And there's no iron in the first one. Was that exactly 40?
That was actually 38. I was just seeing the color change.
Oh, okay.
There we go. 40.
Now you have to put 40 in there too, or no?
I do, yes.
Okay. 30, 40. 16, 49, 22.
40.
40, good.
Okay, so, and as you can see, hopefully on camera you can see just this little bit. You can see that it's changed color. It's a little bit
Tinge pink.
tinge red. Yeah, it's red.
Yeah.
Okay, and as you get up to your higher concentrations, you'll notice a greater change, and you'll notice that they get darker as you go higher up in the concentration. Now, what you're going to do in order to test these exactly, again, you're going to use your unknown, and actually let's just throw these in the unknown just real quick, because I know that this unknown works really well.
Go ahead.
Nitric
you want to
first.
do that one first? Which lid was which?
This one's the nitric. Yeah, don't do that either. Make sure that
Mix the lids up.
Make sure that you recap
look at that
everything
one.
as soon as you're done with it.
Looks like blood.
It does a little bit, doesn't it? Actually,
40.
a lot of it. 40 drops. Now with these, okay, with these tubes, it is imperative that you do not mix them. Okay, you just let them sit. Okay, so they just sit for 10 or 15 minutes before.
Don't shake them?
Don't shake them.
It says in the lab there you can tap them.
Yeah, I wouldn't even do that.
Just let them sit.
Let them sit. The iron will actually dissipate, come out into solution all on its own, and you'll end up with some dark solutions and some light solutions.
Okay.
What you're going to do is you're going to use the spectrophotometer. Wonderful new tool, brand new, like I said before. Okay, if you can in the lab, get your hands on a digital one. Okay, try not to use the ones with the wavy lines. They are they don't work quite as well. They're more here for show than for tell. So what we're going to do is try and use the digital ones if you can.
Sounds
Now,
good.
with the digital ones, the first thing you have to do is you have to zero the spec, or it's called zeroing the spec. And the way you do that, make sure your wavelength is at 590 nanometers.
That should be there when they come in.
It will be. Yeah, it'll be set up for them. Okay, and these are called cuvettes. Okay.
Cuvette.
Cuvettes.
They look like a small test tube.
They that's French.
Cuvette.
Cuvette is French for small test tube.
Did they, or did the cuvette make a pile of money on those?
I think so, yeah.
All right.
And what they are is they're a special type of glass. They're all adjusted to each other, okay? So each of these has been tested so that it gives you an absorbance and a percent transmittance to each other. So it's important that these stay in a set. So once you're done with these, what you have to do is rinse them out with distilled water and just put them on the pegs on the back of the stand and leave them with their box, because these are all calibrated to each other, not necessarily to the rest of the test tubes in the lab. So it's really important that these stay with their box.
Stay with
Can't
their box.
stress that enough. And again, these are about $1,000 a box, so make sure they stay with their box. Now what you're going to do, first of all, this is your control group.
I don't have to measure how much I put in there?
No, you're going to fill up your cuvette. Oh, this is just like the mad scientist on TV, test tube to test tube. Okay, you're going to fill up your cuvette till it's just above the circle on the cuvette.
Just
okay?
above the circle.
Yeah, and this one here, this is your control group, so this should read as a 0 concentration. There's no iron in here, so it should read as 0. So in order to zero your spec, you have to...
So that's what this machine does.
That's
it'll read how much iron is in there. Yeah, or any other kind of ion that I'm looking for.
It reads how much light will actually pass through a solution.
Gotcha.
So this is and it's a measure of concentration, basically. So what you want to do is you want to make sure that, obviously, if we're measuring the amount of light that goes through, we don't want any water spots on the outside. So you just give these a quick wipe with Chem wipes. Make sure it's not paper towel. Please make sure it's not paper towel. Okay, give them a quick wipe with a Chem wipe. Okay, you place your control in there, and you'll notice right away that these numbers jump way up. Okay, probably to around 98. Now, with a concentration of 0, the percent transmittance that goes through that solution should be 100%, because there's nothing in there, so all the light should pass straight through. Right. So what you're going to do is you're going to take the knob on the right, okay, and turn it so that this reads 100%. Okay.
This is sort of like tearing your scale.
Exactly.
Same kind of idea.
Identical idea. Perfect.
It looks like it's very analogy. Finicky.
It is very, very touchy. Okay, 99.8 or 100, about 99, between 99.8 and 102, generally speaking, is about as good as you can do. If you can get it bang on 100%, you are a genius, and you get an A. I'm just kidding. I don't know. You have to ask Jeff about that. But, okay, somewhere around 100%. Now what you're going to do, you take this cuvette out, okay, and you move to your next solution, which is, this was the 0.2 or the second solution.
Yep.
Again, you fill your cuvette up to
just above the 0,
just above the circle. Okay, now this one we would expect to get a different reading, because there should be some absorbance.
I shouldn't mess with my knobs now.
Nope, don't touch anything. As soon as you've zeroed it, it stays zeroed. This cuvette goes in, make sure the line is pointing out, so make sure the line is attached to the line here. We put the cuvette in, and we get a reading of about, for this one here, about 95.6.
So I would write that in my chart.
You would write that in your chart. Now, your chart also requires you to take an absorbance. In order to get the absorbance, all you do is, for the digital ones, is you hit the mode button, and we have an absorbance of 0.02.
Gotcha.
Okay, and you're going to go through this for each of your unknowns. Once you're done going through all of these, or for each of your known solutions and your unknown solution, once you're done going through all of these, you can plot a graph, and you plot your unknown on the graph, and you can figure out the concentration of your unknown. And that's the end of the lab.
Sounds perfect. Now, one thing, just before we dismiss, we should zero this thing each time that we go through it?
Yes, definitely. Before each of your known samples.
So I'm taking this 0.2 one or whatever it was out.
Yeah, taking it out.
So before I do my next one,
put your blank back in. Before you do your next one, make sure you put your 0 or your control group back in there to make sure that it's still reading at 100% transmittance.
That sounds good. All right, so was that all?
That's it, yeah.
So that's it for the lab. So we're looking, our main thing was to take, is this our unknown?
That is your unknown, yeah.
Looking for our unknown, and what we're wanting to know is concentration of iron ions in this thing. Mm-hmm. And we're using this establishing a set of standards, if you can call it that, and using our Spectronic 20D to determine absorbance, transmittance. From that, we'll be able to determine the iron concentration in our unknown.
Perfect.
All right.